Hi, I'm DJ Ware. On this episode of the Cyber Gizmo, we're going to be talking a little bit about so you can use the same commands to talk to FreeBSD, to Linux, macOS, and Windows subsystem for Linux. Yeah, or you can consider this how to talk to aliens, because that's what we're going to be doing. Why would you want to learn the command line anyway? What is so special about it? So first of all, it's faster. You can get things done a heck of a lot faster on the command line than you can poking through a bunch of GUIs. The second is that you gain more control over the machine because you can start services, you can stop service, you can create files, you can create 10,000 files with a single command if you want. You can string commands together and use the real power of what you have under your fingertips. And that is, you can join different commands together to form something new that's never been done before on your machine. So, and you can then use that to do a bunch of things at once too. Did I mention it's faster? It's faster. You're managing on the command line. You can manage multiple files at once, and they can be all over the system. They don't have to be grouped together neatly to do that. The other thing is available anywhere. Anywhere you are, including remote. You can be remote from that machine and still be able to do the same things. Yeah, you could do that with a GUI, but then you're carrying a lot more traffic to be able to manage it over a remote system. And I would submit you're in a less secure environment to do that. You're going to find that if you're applying for a system administrator job, it's required. Yeah, the ability to be able to handle the command line, that's required. But aren't all those systems different? I mean, isn't BSD different from macOS? And isn't macOS different from Linux? And from the command line perspective, no, they're all the same. The only difference that you might have is the options for the command. But I guarantee you, all of them have the same command base because they're all built from the same grandfather, which is Unix. A terminal is all you need to be able to access the command line. So, wait a minute. I had to go hook up some dusty old terminal device with a tube and a keyboard, and no, no. Today, our terminals are software devices, and they emulate what those old terminals did. For example, you have terminals in BSD, you have terminals in Linux, you have terminals in macOS, and you have terminals in Windows subsystem for Linux. You might hear them called shells, but more accurately, they are a terminal utility. So that's a software program that allows you to interact with your operating system with something called a shell. A shell sits between you and the operating system. And there are your terminal program comes with 3 devices. Your shell comes with 3 devices. And that is, those 3 devices are standard input, standard output, and standard error. Standard input is your keyboard. By default, that's your keyboard. So usually you'll hear it referred to as STDN, standard in. The standard output is your screen, usually, and that is its default. You can change it, and I'll show you that in this class. The standard output is usually referred to as standard out. And then the third one is standard error. Standard error is where your error messages go. So why would you put that in a separate file or a separate device? Simple. I could be running along an application and maybe I don't want to see the error messages until I'm done. Maybe I'm testing it and it would just clutter up my screen and make it hard for me to read what's going on. Standard error is where error messages go, and the standard error is referred to as STD error, ERR. We're going to jump down into the command line. We're going to play around with them on all 3 systems just to prove that they're all the same. Let's get started. So I have 3 environments here that I'm going to be looking at. I have a Mac running macOS. I have FreeBSD, and this is running on a virtual machine. This is FreeBSD 13.1. And then I have Ubuntu 22.04.2, and this is a server that is running almost all of my Ansible stuff at the moment. The first command we're going to deal with here is called whoami. Whoami is a utility that's been obsoleted by the ID command. So we're going to cover both of them. But obsolete doesn't mean it's being removed. It just means that there's another command that most people use instead of it. Whoami was really meant to show information about the current user that was logged in. So as you'll notice, all of them have the whoami command available to them. So let's see what happens. It just basically tells you what your effective user ID is. The other one that it supplants or changes is ID. ID gives you a lot more information about your login. So in this case, it's showing me a bunch of stuff here. UID equal 1001, GID equal 1001, and then groups equal 1001 and 27. Over here, I get a different view of it, but it's similar to the start out. It says UID actually has the same number, 1001, and group ID. That's just we're associated with a different user. One of the things that you want to be careful of is what's happening here. Now, FreeBSD, I don't normally have that in my chain. It does functions that are completely self-contained. It isn't dependent upon sending files to other machines or receiving files back. This would have a problem. And the problem that it would have is that my user ID numbers, 1001, over here it stands for Pi, and over here it stands for DJWare. Same down here on Apple. I have a difference. It's 501 and 20. You want to make sure that you try as hard as you can to keep your UIDs and GIDs the same for each user on every machine. And there's ways that you can correct for that. There are, if you can't possibly do that. I know I ran into a company one time that was trying to straighten this mess out, but they had over pretty close to, I think, 75,000 employees. And so it was a chore for them because they didn't have they couldn't put all their IDs in one LDAP server, and so it was just a mess. And it was getting worse because they were acquiring companies that were bringing in even more divergence from this standard. But if you're at home and you're working on a home server, you should try as best you can to keep your user IDs and group IDs for the primary user that you're going to be using to share information with. And the reason why I say that is because you may have unintended consequences with that file if it were to be released by somebody else, right? So it would appear with someone else's name on it on this system, because the only thing the system sees when it moves it is this number. It's this name that associates it. So yeah, that could be a problem. So this is my user ID. It's associated with Pi. It's my username. The group ID is the group that my user ID is associated with by default. So GID is my default group, or my home group, if you would prefer to look at it that way. These are other groups that Pi is a member of. So it's a member of Pi, which is the home group, plus sudo, which allows it to execute as root. We call this, the UID is the real user ID or the effective user ID. And this one is the real group ID or the effective group ID. You'll hear that term on either one. So just trying to bring those terms to your attention because you will hear them again. The commands all have the same meanings from one system to another, but it's possible that they can have different options that you can use between one system and another. So how do you find out what options are available and what the differences are between the commands? Mainly it has to do with the roots of where the commands came from. I would expect these two to be very similar because they both have a common root. I mean, FreeBSD is actually the provider of free and open source to Apple. So a lot of these commands come from FreeBSD. Linux, Linux sort of did everything. They kind of took the basic ideas. This was GNU mostly. GNU sort of followed the Unix constructs for the command names. Each of the systems have their own man page. A man page is a manual that is online, is provided online. So in general, each command that gets each package that gets installed will bring its own set of man pages with it. So when you go out and you install packages that are command line based, they usually bring in man pages with them, so that you always will know what's the current way of using that command. And it keeps it up to date as you update your system. Your man pages get updated with it. So let's try it by itself, and let's see what we get here. So you'll notice that what page do you want? It doesn't know what to do. Doesn't know what to do. But if you want to know if you want to see the command work, you generally have to give it a command name. So let's just feed it man, and we'll do the same thing here, and the same thing here. Let's just do a -a, and then let's put in intro. So this will explain some of the things that you're seeing in the man pages, and you can get all of these. A will list all of them. So we're looking at the introduction to the user commands, and that's section 1 of the manual. So intro with a parentheses 1 is section 1. That's what the command belongs to. So if I quit this and go to the next one, you'll see that intro 8 means that's the programmer's manual. So let's do it again. I'll quit. I'll go to the next one. This is the introduction to the library functions. That's section 3. And then, we'll just keep going through them. Section 2, system calls. Section 5, introduction to file formats and file systems. And intro 4 is introduction to special files. And then 6, introduction to games. And 7, introduction to overview and miscellaneous section. So if I wanted to find something like, let's say hostname has a conflict, right? So if I do hostname, I'm going to get section 1. Maybe that's not what I want, though. Maybe I want to see what the hostname looks like for the programmers. I can put in, you can do this a couple ways. You can do a .7, and that'll bring up the programmer's manual and show me the hostname resolution description. So now I've got this mess, right? I've got this mess, and I need to clear off my screen. There is a terminal name that describes how these respond to different characters that it receives. So when I'm doing a clear, the command that I want to run is a clear. When I'm entering that command to do a clear, it's actually going and looking up the terminal construct for how to clear a screen. And in that construct, for that terminal definition, it will find a sequence of characters to send that will properly clear the screen and put the cursor as high up on the page as it can. So let's do that. Let's do a clear on BSD. And you'll see that it cleared everything off and moved everything up. And I'll do another one here on Ubuntu. Similar behavior, but there are some differences, and we'll talk about that in a minute. So let's talk about the next thing. So if you'll notice this here, and I haven't described any of this yet, so you have this prompt here. This has a prompt here, and this has a prompt here. And then there's the cursor that's sitting there as a block on all of them. So that is, by the way, a standard, but this part is not. You can make that anything you want. I've seen people have unicorns in there, and I've seen people have multi-lines and all kinds of fancy displays. So what is displaying here right now is my user ID. The @ means This is the host following. So this is the host name. A colon says that's the end of the host name, and then we have a little squiggle here. What the heck is that? Well, as it turns out, in Unix and Linux, anytime you see the character tilde, and that's what that is, that's a tilde. Tilde means that you can, that is your home directory. So that's a shorthand for your home directory. How do I know what my home directory is on these different systems? Well, I'm in my home directory, and if I were to do a print working directory, it would show home pi for the Linux machine. Print working directory. It's going to show home djware for the FreeBSD. Apple's going to be a little different because they store their users in a /users directory and djware. How do I know what's in? I'm sitting in a directory, right? So how do I find out what's in it? How do I find out what's in my directory? Well, I can do an ls, and then I get a list of stuff, but I don't know what that stuff is, and some of it's green, and some of it's blue, and some of it's red. I don't know what that is. And I can do the same thing over here, and that's all white, and I don't know what that is. This is all white, and I don't know what this is either. In order to find out what things are, you do an ls minus l. How do you know that? You can do a man ls. And we can come down here and we can look for, you can see there's a whole bunch of options. Use a long list format. Okay, that's what that means. And if I do a long list format, I get this, and if you're not familiar with the command line, you'll notice that there's this, some weirdness here, and then there is another number, and then there is 2 pies, some more numbers, looks like a calendar date, and then maybe a time, and then it looks like a name for a file, right? All right, so let's explain this. This particular one right here is an indication, this first column, where it's either a D or a dash. A dash means it's a file. A D means it's a directory, which a directory has a special kind of privilege in that you can store files inside of that directory. So the next 3 characters have to do with my user, what my user can do with it. So these are the permissions on the file. So it means that in this first group of 3, read the RWX means that I can, that pi, this pi user, which is this column right here, that's my user, this is my group. So then I read, write, execute. So my user can read the file, it can write on the file, it can execute the file if it's executable. That's pretty common for a directory to have that in there. So it just means that I'm going to allow execution out of the directory. You don't have to. All right, so the next group of 3, I have an R, a dash, and an X. That's my group permission. So that means the pi group, anybody, and I can put other people in that pi group, but anybody other than the user pi only has read and execute privileges on it. They can't write to the file. And then this last group of 3 is everybody else, or sometimes referred to as the world. That means that everyone can read and execute, but they can't write to it. And you'll notice that some of these files up here, they don't allow anything. So this rocks.m3u, the default permissions is read write for the user pi. The group only gets read and everybody else gets nothing, no access at all. Same here. It's exactly the same here. And exactly the same on Apple. They all follow the same convention in how the directories are passed and how they look. All right, let's go ahead and talk about the rest of it. So we have this number here. I'm going to skip over that one. So let's just talk about this. Is the length of the file in bytes. This is the date the file was either created or modified. So if I have a directory, let's see if I can find one. This one has something in it. You'll notice that I did something there, right? Where the name popped out. So your shell has a shorthand. I'm going to CD, which says to change directory. So one of the things I want to show you before we do that is what happens if I do a man on CD. So I get a no entry for CD. I get a built-in over here and a built-in over here. This is, by the way, the correct way of doing it. This is incorrect. The shell command has the ability to execute commands within itself. So a built-in command means that it's not going to go out to the disk and retrieve an application and start executing it. It means that the shell itself has the capability of handling this for us. And so when I do that man, it says, oh, all of those are built-in commands. All of these are built in. So you'll notice there's CD right there. Same with the Apple. This incorrect way to do things because you don't know. This would indicate to me that there's no man page for CD, which isn't true. The shell is handling the CD because I'm going to be able to type in CD here in a minute. There's one right there, Spectre Meltdown Checker. All right, so let's try that. So I can start typing in all of this, and I could keep going. That's a pretty long name. If I hit Tab, it will find the rest of the file. So this is just changing my current directory, and you'll notice that my prompt adds on that directory name. I'm in my home still, but you'll notice that I have this slash now, and it says that. So it found this file in my home directory, and there's another directory there that I've loaded to. Same with documents, same. Okay. And then this one shows me that I'm in Saturn's directory here as well. So how do I get back out of this? There's two ways to do that. I can do a CD tilde to do that, which takes me to my home directory. Or I could just do a CD by itself, which says, take me to my default home location. And that is defined by a variable. And that variable gets populated at the time that your password and your user ID and password get set up. The administrator can specify where your home directory is. So same thing here. Oops. I'm now returned back to my home directory, and I can prove that. There's where I am. Now it shows me I'm in the Saturn directory. What if I want to create my own directory? In this case, these are real commands, not built in. Those are similar. And then over here you have all kinds of, they have modes and all that stuff. So you can specify ahead of time what you want the permissions to be for it. Whereas over here you do it, you can also do it that way too. I'm not going to cover modes today. We'll cover those in the future. But let's just do just give it the name of the directory. One thing I should show you though, if I do that, if I do class 1 by itself, you'll see it says total 0. You're going to go, what? They all have this same behavior. What it's doing is the shell knows that class 1 is a directory, and instead of listing it, it's going ahead and looking at what's inside of it. If I do an LD, this time it will say, don't jump into the directory, just tell me just show me the entry for it. And they all do it the same. The make directory is always followed by what we call an argument. An argument isn't you're not getting into a fight with your computer. All you're doing is you're supplying a variable with a value. You're passing a value to a variable that it needs in order to create a directory with that name. That's it. So if I want to remove that directory now, you'll notice that there was nothing in class 1, right? So if I can do and you'll see that it says remove the directory if they are empty. So it means that you can't have any files or directories in class 1. So if I go to class 1 and I make a directory and I try to remove class 1, it's going to complain, right? If over here, though, I don't have anything in it, so let's go ahead and do that. So now we're having a real argument with the machine. So how do you deal with this? Well, I could go in to class 1, and I could look at all of those by doing an ls-r. That's a recursive. So it says go to the first directory, list what's there. Go to find the directory that if it is a directory, then go to it and look at the files. Go to it and look at the file. So I can do this. Right, I can do all that, but if I had 100 files in here, that might that were 3 or 4 directories deep, that could be tedious, right? That could take all day. So there is a shorthand, but you have to be really careful with it. Make sure you know where you are before you start. Many a person has been working under root and started at the top of the directory. If I do an ls, that's the top of the Linux directory. Every file you have is under this organization. And so I'm going to show you how to remove the directory, but I'm going to tell you be careful when you use this. So here's where I'm at. There's my class 1. So I'm going to tell it remove recursively. That says every file I want gone, even if it's in a directory, and force it, even if it isn't empty, to be removed. And then I want to start with class 1. And so you see that it came back, no news is good news. That means that it's gone, doesn't exist, and it's gone. And so is second hour, so is everything. I have seen more than one person do this, so including me. On multiple occasions, I have done this multiple times. I mean, it's easy to do, especially if you're executing as root. The next command we're going to look at is touch. The touch utility sets the modification and access times on a file. It can also do it for a directory as well. But if the file doesn't exist, touch will create it. I got rid of class 1, right? So let's go ahead and recreate class 1. We'll go ahead and do it here too. All right. So you'll notice that it has a timestamp of 1714 on it. We'll get it eventually. 1714. 1714. 2314 because this one is in a different format, but different time zone. So let's go ahead and go into classical. And so everybody is in there, right? Nope. Let's start with BSD this time. So if I type touch, it just created the file with the current time. We can prove that. Oops. Did it again. All right. And there's what we have. So, and that's all the touch command does. If I come back to this, you'll notice that it's been updated. It says 1715. So the system automatically updates the directory based on the contents of what's in it. So if I look down through, I'll see that the newest file is 715. The same thing happens here. It'll do the same thing here and also here. Okay, so the next command we're going to talk about is move. The move command renames the file and in one particular form, and in the second way, it can move one or more files to a different directory. So let's just try this first. So let's say I want to move. Let's remove second hour. And let's say that we're going to move the first hour to the second hour. There we go. And so it's renamed the file. All of these work very similarly. That renamed it. There you go. So let's say I want to, by the way, you can pattern match on a file name. So this is saying list everything that begins with test, but the fifth character, I don't care what that is. And so it picks test 1 through test 5, right? There's another, as you notice, it didn't pick up the test file though. So I can also do it this way, and this time it'll pick up anything else in there, so there's a test update as well. But I only want to mess with test 1 through 5, so let's say we want to move to the directory. Now I don't have my other ones again, so there's my files. They're gone. And now they're back. So that's how you can do that. Those are the two. So I can move a single file and that will rename it. If I move multiple files, it will into a directory, It'll actually move them from their current location to the new location. Copy is where you want to leave things in their same place, right? So let's try that. So let's look at class 1, and this time we're going to copy the same thing. Okay, so my test ones are still there, but I now have copied them over here. And again, so let's do the same thing. Let's do a copy. There's my test. And there's class 1. And there you go. So that's as far as I'm going to go today. It's one of the few places that, and we worked hard on this. I mean, yeah, we spent years trying to get people bent to having a common command base, because before this happened, it was chaos. Everybody had a different command base. The mainframes had a different command base. The Unix machines had a different command base. The DEC machines had a different command base. It was a mess. And finally, the world decided, you know what? You're right. We need to get down to one command base so that our system administrators don't have to keep memorizing different commands for different systems. Okay, so we've looked at 14 commands or so. I had hoped to do 15, but one of them has a problem, which is open. So yeah, I'll look into that and we'll add it to the list for next time. So for the next time, yeah, I have more on my list of things to show you. So for now, go try out what I've shown you, and try it out on your different systems. Try it out on Windows Subsystem for Linux. I can't show you that because I don't run Windows. Go talk to some aliens and see how well it works for you. Hope you enjoyed this video. If you did, please like and subscribe. Hope to see you again soon. Bye for now.